Okay. Yep, we're going to go over it right now, Katie. All right. So, from yesterday, Power Standard 7, ICANN Statement 1, I can name and identify angles. Now, the angles we already named and identified were acute, obtuse, right, and align. Acute is less than 90. Obtuse is more than 90. A right angle is exactly 90. And a line is 180. The one that we talked about yesterday was called vertical angles. And we said vertical angles, opposite, which is the key word, opposite angles are congruent. And then we went over some easy ones where you're not allowed to use a protractor. You have to use that definition to help you find the measurement of missing angles. We discussed yesterday that when two lines intersect, 4 angles are formed. And what's the sum of all 4 angles, Olivia? No, what's the sum? S-U-M. What's the sum of all 4 of these? 360 degrees. Right. And Destiny, what's so special about these 2 angles? Well, what do they come out to, though, when you add these? 180. Good. Very good. So, I'm standing at angle 1. I look across the street. So how many degrees is angle 1? Harris? Yes, sir. They are equal. So if I'm looking at across the street from angle 2, Sebastian, what do we got? All right. Those are easy. Correct?
Yes.
All right, now let's talk about the more difficult ones. The ones that have variables. Ooh. Let's go 4x minus 8. Let's go 2x plus 12. Let me zoom in a little bit for you. Now, these are vertical angles because they are opposite one another. Because they are opposite one another, they are equal to one another. So I can take this first expression and set it equal to the other expression. How do I know they're equal? Because of this definition. Opposite angles are equal. Because of that definition, I know that these 2 angles opposite each other are equal. Because of that, I can set them equal to each other. So if this angle is 95, that angle is 95. If this angle is 98, that one's 98. If this angle is 100, that angle is 100. they are equal because they are opposite each other. You guys got that?
Yeah.
Good. Now, how the heck are we going to solve this thing? Somehow, I have to take this 2x and I have to group it. I have to combine it with the 4x. So how are we going to do that? Aiden?
You bring the 2x down, make it a negative 2x.
Right.
And then you put a negative 2x under the 4x.
Right. We call that the inverse. Because inverse means opposite. And because we added a negative 2x to each side, the technical term is called the additive inverse. I'll write it down for you. Additive inverse. That's what we applied. Additive inverse. There was nothing down here, so we added a negative 2x and we added a negative 2x. To both sides of the river. To both sides of the equal sign. 4 minus 2.
2.
These 2's cancel out. And we're left with 12. Now I need to get this negative 8 and combine it with the 12. How are we going to combine the negative 8 with the 12, Katie? Add what? How are we going to add each other? Very good. We're going to add 8 to both sides. And we get 2x, those cancel, equals 20. So now if you notice what we have variables on the left, we have the constants on the right. Variables on the left, constants on the right. We're almost done. What's the inverse of multiplication? Division. So just divide by 2. And there's your answer. X is 10. Okay? You guys ready to try one on your own? Okay. If the majority of the class gets this, then we can move on. I'll make this one easy for you. We'll go 6x minus 12 and 3x plus 15. They are opposite, which makes them equal. Oh, it doesn't. Give you a couple more minutes to work on this. Remember to apply the additive inverse. If it's a negative, you would apply a positive. If it's a positive, you apply a negative. That way, they cancel each other out. You have a question? Okay. Kaylee, did you get an answer? What'd you get? X equals 9. Holy smokes. That's what I got. Nice job, Kaylee. So notice what I did. I set the two expressions equal to one another. I took the 6x minus 12 and set it equal to 3x plus 15. I looked at the 3x. I knew I had to get this 3x to the left side of the river so that it can be combined with the 6. This 3 is positive. What's the opposite? Negative. So I added a negative 3 to both sides. I got 3x minus 12 equals 15. Then I knew I had to get the negative 12 to the right side of the river. And because this was a negative 12, the inverse of negative is positive. So I added a positive 12 to both sides and got 27. And then I just divided by 3 and got x equals 9. How many people got x equals 9? Raise your hand. All right, majority. Good. Good. We will practice these a ton, okay, today. All right, we are going to start. We talked about that yesterday, so we're going to take some new notes today. And one of the first vocabulary words I want to talk about is adjacent. Adjacent angles are two angles that share the same vertex. Two angles that share the same vertex. Here's an example. Okay. How many angles do I have right here? How many angles do I have right there, Stephanie? Right here. How many angles do I have? 3? 3 angles. Nope, I do not have 3 angles. No way, no how. Adriana, there's 1. Can you name it for us? It is an acute angle. And what's the name of that acute angle? Hannah?
You mean like ABC?
ABC. Easiest 1, 2, 3. Michael Jackson, Jackson 5, never? Oh, okay. You were looking at me like you had no idea what I was singing. There is 1 angle here. Notice what the definition says. 2 angles that share the same vertex. You guys see A, B, C. Which one of those letters is the vertex? A, B, or C? Michael. B is the vertex. Now, to make this adjacent angles, we need another angle. So watch what I do. And now look. I have angle DBA, and I have angle ABC. I also have angle DBC, is the whole thing. That would be correct. That would be correct. That is called adjacent angles. This is non-adjacent. Watch this. See how I kind of separated them from one another? That's called non-adjacent. Okay, I could put them together, and then they would become adjacent. Take them apart, and they become non-adjacent. What makes them non-adjacent is they don't share the same vertex. They're not laying right next to each other. Okay? When my kids were younger, they slept in the same room together. They were adjacent to one another. Now, my 4-year-old sleeps in one bedroom, and my 2-year-old sleeps in another bedroom. They're not adjacent. They're not laying next to each other anymore. This is them laying next to each other. This is them laying in separate bedrooms. Now, how are we going to use this to our advantage? How can we use this? We are going to use this with these two other definitions. We have complementary angles, and we have supplementary angles. Supplementary and complementary. Complementary, two adjacent angles whose sum is 90 degrees. Supplementary to adjacent angles whose sum is 180 degrees. We've already talked about this one. When you guys were doing your protractor practice, on that packet that you turned in yesterday, on the first set of problems, number 5, it was a supplementary angle. In fact, today, we talked about supplementary angles. Let me show you. I asked at the beginning of class, Destiny, what's special about these two angles? And what did she say? Well, Mr. Meeks, they add up to 180 degrees. These two angles here are supplementary. These two angles here are supplementary. Angle 1 and 2. All right? So we've already discussed supplementary angles. I'm just now putting a specific name to it. All right? That's what they're called. You need to know that. So, again, how is this going to help us to our benefit? Knowing these two definitions. So looking at the first example here with complementary and supplementary, the first example, are those complementary angles or are those supplementary angles? Oh, jeez. Thanks, Ms. Kay.
You're welcome.
Hannah?
Complementary,
Why would you say complementary?
because the sum is 90 degrees.
Very good. That is a right angle, correct? And in a right angle, which we talked about last week, forms 90 degrees. So if ABC is 18 degrees, how much is CBD going to measure? Sebastian? 72 degrees. And Sebastian, can you explain to the class how you got that? Very good. Very good. Questions? No? All right. Let's take a look at example 2. James, is that complementary or supplementary? That's complementary. Just like this one. That one's complementary. Why would you say supplementary? Right. Right. This one angle already is over 90, so there's no way it can be complementary. Plus, anytime that you see a line, all right, a line has 2 arrows. A line goes in opposite directions forever. As soon as you see that line, you know you have 180 degrees. So if angle ABC is 110, what's CBD? 70 is correct. Thank you. So now watch what we're allowed to do. Remember, yesterday and today, look at how many angles I gave you. 1, 2. And I said, don't use a protractor and tell me exactly how much angle 1 and 2 is. Now watch this. Now I'm only giving you one angle and asking you without a protractor, tell me exactly how much angle 1, 2, and 3 are using the definitions vertical, complementary, and supplementary. Using those three definitions will allow you to tell me exactly what the measurement of angle 1, 2, and 3 are. Anybody want to start off and give us 1, 2, or 3? Aiden?
2 is 115 because it's right next to the street.
All right. Angle 2 is 115 because these two angles are what we call vertical angles. The other Aiden.
Angle 1 and 3 are 65.
Angle 1 is 65. How did you get that?
180 minus 115 is 65.
These two angles are supplementary. 180 minus 115 is 65. And angle 3 has to be 65 because opposite angles are equal. Very good job. Very, very good job. All right. Let's do one more, what I call easy problem, and then we're going to start doing some with variables. All right, number 4. Let's do... Just so you know, you are allowed to use calculators, so if you want to grab a calculator, you're more than welcome to. It'll help you out with addition, subtraction. You can go get one.
Gosh.
Just stretching. Katie, do you think you can give us one of those angles? 1, 2, or 3? All right. Number 2 is 92. I agree with that. They are opposite. Nicole, can you give us number 1 or 3?
Number 1 is 88.
Number 1 is 88. I agree with that because they are supplementary. And Nathan, what about number 3?
It's 88 degrees.
Very good. Because if 1 is 88, number 3 has to be 88. Any questions? Okay. What time we get out of here? 53? So we have 15 minutes. Perfect. All right. You guys ready to rock? Oh boy. Now comes the fun stuff. So let's go 6x plus 15 and 3x plus 5. And the directions are going to say, find the value of x. What numerical value does x possess? Now, the first question I'm going to ask you is this. Am I going to set these two expressions equal to one another? No. And let me tell you why. Okay? Let me tell you why. Correct me if I'm wrong. This angle right here is obtuse. Right? That's bigger than 90. And correct me if I'm wrong, but this angle right here is acute. Right? Which is less than 90. So how could can anybody think of a number bigger than 90 that is equal to a number less than 90? 80.
180.
Okay, let me ask that question again. Can anybody come up with a number that's bigger than 90 equal to a number less than 90? Yes, 180 is equal to itself, but it's not less than 90. Katie, is 50 more than 90? No. I need a number that's bigger than 90 and less than 90. How much? Oh, I thought so. Emma, 90 is not bigger than 90, and 90 is not less than 90. I need a number that's bigger than 90 and less than 90. 80. Okay. Christian? I don't need. There isn't one. You can't. There is no number that can be bigger and smaller than 90 degrees. It's either going to be one or the other. The reason why I'm asking you this is because of this problem. This is an obtuse angle. It's bigger than 90. This is an acute angle. It's smaller than 90. With that being said, these two expressions can never be equal to each other, because there is no number bigger and smaller than 90. So every single time you are given a problem that looks similar to this, where the two angles are adjacent and form a straight line, we are going to take the first expression. We are going to add it to the second expression and make it equal to 180. Why 180? Because those two angles form a straight line. We're not setting them equal to one another, because there is no obtuse angle or an acute angle equal to one another. There is no number bigger than 90 that is also less than 90 degrees. So now we need to do a process called, which you might have heard from last year, combine like terms. Have you ever heard of that phrase before? Okay, we are going to combine like terms. We are going to combine the 6x and the 3x. Notice I circled them. And not only did I circle them, but I also took the sign in front of the number. That'll tell you whether to add or subtract. So this says 6x plus 3x. What's that equal? 9x. And then what's 15 plus 5?
20.
20. Are all the letters, are all the variables on the left side of the river? Yes. Are all the constants on the right side of the river? No. I got to get this one over. Somehow I got to get this 20 over with the 180. How am I going to do that, Emma? How am I going to get this positive 20 over here with this friend?
Well, negative 20 under 20.
We're going to add the inverse. Very good, Emma. Very, very good. And when we divide these, we get 17.7. It's similar to what we've been working on with setting the expressions equal to one another. You're still going to use the additive inverse. You're still going to divide at the end to get your answer. All right, let's try another one of these. And then I'll give you guys your practice work. Oops, sorry guys. That should be 15x plus 12. Am I going to set these two expressions equal to one another, or am I going to add them and set it equal to 180? Christian? Correct. Absolutely correct. 15x plus 12 plus 3x plus 24 equals 180. Now we have to combine like terms. We're going to combine the letters. We're going to combine the variables. We're going to combine the constants. I put a square around those. John, how am I going to get the 36 over with the 180? How are we going to move this over? What are we going to add to both sides of the equal sign? And what's the inverse? Yeah. Right. Yep. You're absolutely right, John. We're going to add the negative 36 to both sides. And we get a 18x equals 144. And now what's our last step? What do we do at the end, Alex? What are we going to divide by? And x equals 8. All right, so you guys are going to have a whopping 3 problems for homework. I know it's a lot. I apologize, but you need to practice these. So here is your practice work.
Please excuse the interruption. Can the following students when the bell rings? Hannah Gibbons, Jacob Chambers, and Joseph Roy. Thank you.
So for number 2 and 3, you need to find the value of x. If you need to take a picture of that because the bell's about to ring, you're more than welcome to. If you need help with this, I video recorded this, so you're